Okay, let's try this again. Okay, so people at home, we had a fire drill, so we'll start this all over again. Our unit circle quiz is going to be next Wednesday for people at home, and we are on worksheet 2-2, and we are on problem number 39. Problem number 39. So people at home, if you don't have your unit circles out, you want to get unit circles out, and we're going to work through these. So again, nothing different here when we get to 39. It's just they're giving you the angles measured in radians instead of degrees. So when we look at these, we have number 39. They ask us for 2 sine of pi over 3 plus something, 39, no, minus 3 tangent. Minus 3 tangent of pi over 6. Okay, you guys got your unit circles out there. So 2 sine pi over 3 means 2 times the sine of pi over 3. And what is that? 2 times radical 3 over 2, is it? Is that correct? You guys got the unit circles. Let's see how well you guys can make sure you can read them. The sine of pi over 3. See, that makes 60 degrees.
Radian 3 over 2?
Radical 3 over 2? Yep.
Yeah, whatever.
Yep. Radical 3 over 2? Yep.
Starts with an R, that's all I know.
Yep. Minus 3. And then the tangent of pi over 6. I think that's radical 3 over 3, isn't it? Tangent of pi over 6.
Yeah.
Okay. Radical 3 over 3. This one's actually pretty nice. This actually turns out really, really nice. These 2's cancel. So we're left with radical 3 minus these 3's cancel. So we're left with radical 3. So the answer is 0. Goes all the way to 0. Okay, so that's kind of nice. You want nice and pretty. 41. Okay, sine of pi over 4 minus cosine of pi over 4. Cosine of pi over 4. Okay, so the sine of pi, I'm going to shut my mouth and have you guys try this one on your own. The sine of pi over 4 minus the cosine of pi over 4. I think you got it? Is it what?
0.
It's definitely 0. What's the sine of pi over 4?
Radical 2 over 2.
Minus cosine of pi over 4.
Radical 2 over 2.
You don't need a calculator for that. If you subtract something from itself, you always get 0. Fantastic. 43. Okay, 2 secant of pi over 4. Then what? Plus 4 cotangent of something of pi over 3. Okay, so again, we don't have secants and cotangents written on our unit circle, but to find secant, we flip cosine. It's a reciprocal of cosine. To find cotangent, we flip tangent. So 2 times, we look up, again, for secant, well, first of all, we look at pi over 4, which is 45 degrees, and the cosine at pi over 4 is radical 2 over 2. So the secant is 2 over radical 2, and we'll deal with that in a minute. We can't have radicals on bottom. We'll deal with it eventually. Okay, so it's okay if we have radicals on bottom right now, as long as our final answer doesn't have radicals in it. Plus 4 times, again, cotangent, you look at tangent, and you flip it. So at pi over 3, what is that? Is that radical 3 for tangent, I believe it is? So the reciprocal of radical 3, we learned this little shortcut yesterday, is radical 3 over 3. Okay? Okay, so let's clean this up as good as we can. It doesn't look very good right now. Let's, over here, times the top and bottom by radical 2 to get rid of this radical on bottom. So we do that. We have 2 times radical 2, which would be 4. Radical 2 over 2. Radical 2 times radical 2 is radical 4, which is 2, plus 4 radical 3 over 3. And we can clean this up a little bit. 4 over 2 is the same as 2 radical 2 plus 4 radical 3 over 3. And that's as good as it gets, okay? Other than some people could argue this. Some people say that's in simplest form, or some people might do this. Get a common denominator, times by 3 times by 3, and you have 6 radical 2. So I mean, This one is better because you have a common denominator, but there's more junk. This doesn't have a common denominator, but there's less junk. So which is better? I don't know. I mean, I was just left it as this. Okay. There's nothing wrong with this answer, but I would say that's I don't know, probably the simplest answer. So that's not a very good answer, okay? But sometimes they come out like that. Okay. 45, just a couple more of these types of problems. 45, the tangent of pi minus the cosine of 0. Okay, oops. Cosine of, hey, the cosine of 0. Okay, I'm going to shut my mouth here and have you guys give this one a shot. Is that 0 degrees or 0 radians? It says cosine of 0. Is it 0 degrees or 0 radians? Why do you say that?
Just specify degree.
Okay, you guys aren't wrong. I was hoping somebody will say something besides that. Huh? I agree, there's no degree symbol. So you'd say, you're not wrong when you say it's radians, but let me ask you this. In a track race, before the gun goes off, does the clock say 0 seconds or 0 minutes or 0 hours? So is it seconds, minutes, or hours? It doesn't really matter. I mean, what's longer, 0 seconds or 0 minutes or 0 hours? They're all the same. I mean, 0 radians and 0 degrees, it's 0, 0, okay? So, I mean, technically it's radians because there is no symbol, but 0 degrees and 0 radians, it's the same thing, 0, 0, okay? So, what is the answer? 0. What do you guys get for an answer here? Do they have a guess? Or I'll shut my mouth here for a couple more seconds. Find the tangent of pi, write it down, and then find the cosine of 0, write it down, and then subtract them. Any guesses? Negative 1 minus 0? Okay, what's negative 1 minus 0 then? Okay, what is negative 1 minus 0? Negative 1. Yeah, just negative. I mean, it's not wrong, but it's negative 1. So the tangent of pi is 0 minus the cosine of 0 is 1. 0 minus 1 is negative 1. Now, if you're sitting there going, I thought the cosine of 0 was 0, that's the sine of 0. Okay, remember it goes cosine sine. Okay, cosine sine, not sine cosine. A lot of students make that mistake. 47, the cosecant of pi over 2 plus the cotangent of pi over 2. Okay, so for cosecant, remember, you flip sine. I mean, a little visual that you really need to have down is this. Sine, cosine, tangent, cotangent, secant, cosecant. Reciprocals, 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 okay? So whenever I write those 6 trig functions, I always write it like that. 2 columns of 3. So we look at pi over 2, and we look for the sine first. The sine at pi over 2 is what? 1. Flip it. Still 1. Cotangent of pi over 2, this is a little bit, okay, this is a little bit tricky. This is not mathematically correct. I'm going to say something, I think you guys will get it, but it's mathematically incorrect. It doesn't really make sense. For cotangent, you look at tangent, okay? Tangent at pi over 2 is what? It's undefined. It's not a number, okay? But I'm going to ask you to flip undefined, which doesn't make sense. I'm asking you to flip a number that doesn't exist, okay? Do you know what you get if you flip undefined?
Well, wasn't it that?
0.
Flip 0 and flip 0 to undefined.
Right, yep. So you see what I'm saying though? If I say flip undefined, that technically doesn't make sense mathematically. You can't flip a number that doesn't exist. But what we have here is, if I gave you 0, the reciprocal of 0 is undefined. Therefore, the reciprocal of undefined would be 0, okay? So, you guys get what I'm saying there? So, if something's undefined, if you flip it, it's 0, okay? So the answer is 1 plus 0, which is 1. Any question on these? Okay, when we get to 49, these are kind of like the ones that we did at the very beginning of this worksheet, okay? They ask you for, some writing to do on these, okay? They ask you for all 6 trig functions, okay? And you're going to want to use your unit circle on this. So at number 49, because I don't think these are especially tough, it's just a lot of writing. Our angle is 2 pi over 3. So I want to find the sine of 2 pi over 3, the cosine of 2 pi over 3, the tangent of 2 pi over 3, And again, you don't, I would encourage, I really would wish you would do it this way. I wouldn't write the other three beneath it. I would put cotangent right here. I just think it's a good habit because it just helps you remember that cotangent and tangent are reciprocals of each other. Have secant go across from cosine, and have cosecant go across from sine. That'll help you memorize what's the reciprocal of what. Okay, so we look at our unit circle at 2 pi over 3, and we ask ourselves what the sine is. The sine at 2/3 pi, what is that, radical 3 over 2? Okay, remember it's the y value, radical 3 over 2. If I told you you didn't need to simplify it, we're going to simplify it, but if I told you you didn't need to simplify it, you should be able to tell me cosecant right now. Cosecant would be 2 over radical 3. But we have to get rid of that radical 3 on top and bottom. Times radical 3, times radical 3. 2 times radical 3 is 2 radical 3. Over radical 3 times radical 3 is radical 9, which is 3. Cosine. What is that, a half? So you should be able to tell me secant right now. 2 over 1, which is just 2. Okay? If you put 2 over 1, I'm not going to mark you wrong, but 2 is a better answer. And then for tangent, we look at that, and it's what, radical 3? And the reciprocal of radical 3, I showed that little shortcut, is radical 3 over 3. Oh, that's wrong. Cosine's negative half, isn't it? Why? One word. Left. Good. So that's not 2, it's negative 2. Speak up. If I make a mistake, speak up. Okay. Sometimes I make, you guys know from algebra too, that I would make mistakes all the time on purpose to have you catch me. That's what I just screwed up on. So, and tangent's negative also because a negative and a positive divided is a negative. Yep. All right. 51. 210 degrees. Oops, 210. So we have the sine, the cosine, the tangent, 210. I tell you what also, to save you a little bit of writing, and I think I've told you this before, that if you take trig or any other high-level math, any class, forget about math, any college class, if a professor tells you to do something, you do it, okay? And what I mean is this. Usually at this point, a student will say, can I just write this? Can I just write 210 and then write sine equals, cosine equals, instead of writing 210 every time? I don't care. I really don't. I mean, put the angle up there to start with, okay? But if you don't want to write the angle, I don't care. Now, what did I talk about college for a minute? If your college professor says write it, you write it down. If he says write it down and you don't write it down, he marks you wrong, that's your fault, okay? You have no argument. He told you to do it, you didn't do it, he marks you wrong, okay? But I will tell you this, it doesn't really make sense to do that, and here's why. I'll give you an example that you guys all know, okay? If you don't need a calculator, you shouldn't need a calculator for this. If you had a calculator though, what's the square root? Why isn't anybody answering? What's the square root? Who said that? I heard somebody say it. Of what? It doesn't make sense. The square root of what? Okay, now if I said the square root of 100, you say 10, okay? But the square root in and of itself doesn't tell you. So if I say, tell me this, tell you what, forget this question, okay? Look at your unit circle, give me the tangent. Of what? It doesn't make sense, okay? So to just say sine is this, you really should say sine of 210 degrees. Am I gonna mark you wrong? No. Will a college professor mark you wrong? Maybe, I don't know, do what they tell you, okay? So just to save you some time, I don't care if you do that. Secant, cosecant. Okay, so at 210 degrees, the sine, what is that? Is that negative half?
Yeah.
Negative half? So what's cosecant? Negative 2 over 1, which is negative 2. Okay. Cosine, was that negative radical 3 over 2? Okay. Secant would be negative 2 over radical 3. You guys need to help me out here because I don't want to lose anybody right here, okay? Are we okay if I just put this down right here? I don't want to lose anybody right here. Speak up. Do you know what I just did without showing my work?
Yeah, we got it.
Okay? So I just times the top and bottom by radical 3. That's all I did, okay? I will tell you something else. When you go off to college, just a little bit of advice for you and all this. We always tell you, show your work, show your work, show your work. When you get into higher level math, like for example, if I give you something such as this, This is not higher level math right here. 13. If I did this right here, did I show all my steps? No. Do you know what I'm doing? You should. I mean, you really should, okay? Without showing any, how did I get from here to here? What did I do?
You combine
I
that.
combine like terms. How did I get from here to here? Subtracted one from each side. How did I get from here to here? Divide by 12. When you're taking algebra and so forth, they want you to show your steps. Show your work, show your work. When you get further along, just a little heads up, 'cause I remember I actually had a